Hello, good morning, and a very warm welcome to IMR's webinar this morning on shatter-free machining. Optimize your CNC machines with tap testing. I'm your host, Gary Dorn, and this morning I'm delighted to be joined by Kevin Mungy, a senior researcher here at IMR in the subtractive manufacturing department. Kevin's research involves exploring the latest trends in CNC machining, which includes, of course, machine optimization with techniques such as tap testing, tool balancing, which will be covered in this webinar. We are also joined by the Director of Subtractive Manufacturing at IMR, Chris Judge, who I'm sure many of you will already know. His expertise lies in his experience growing advanced technology and modern precision engineering companies in a fast-paced environment. Chris has extensive experience within the precision engineering sector, working with technologies from CNC machining and abrasive water jet cutting to EDM. Let's welcome, first up, Chris Judge. Good morning, Chris.
Good morning, everyone. Thanks, Gary, for the introduction, and thanks everyone for joining this morning. Hopefully we can go through this quite smoothly and give off some good information around the work that we've been doing in IMR. And as Gary said, if you have any questions, please stick them in the chat. Just a little bit about IMR for those who are not familiar with us. We are a non-for-profit research organisation that is set up to help Irish manufacturing companies across various sectors to explore new and emerging technologies. And our motto or ethos is to demystify, de-risk and deliver new and emerging technology. So as technologies are coming to the market, we try to help companies to explore those technologies. And in our research facilities in Mullingar, we have a number of industrial pilot lines and test beds, CNC machines, robotics, automation. And people can try those pieces of equipment or test them. They're the latest state-of-the-art equipment. And we can do a lot of prove out and prototyping and testing research on them. And on the next slide, you will see that IMR work across a number of thematic areas. We do a lot of advanced automation and control and robotics, design for manufacturing, which precision engineering sits underneath, where you will have design simulation, you will have additive manufacturing. We have a lot of equipment in additive manufacturing, 3D printing, metal polymer printing, and digitization, which would include anything related to IoT capabilities, machine connectivity, visualization of data, and software, a lot of in that kind of space. And then one of our biggest themes at the moment is in growing quite handsomely is the sustainable manufacturing side. So helping companies become more sustainable. And again, this is all across different sectors from pharmaceutical, medical device, precision engineering, food manufacturing, furniture. Anybody that's manufacturing in Ireland, basically, we will work with those companies to try and help them with the latest technologies that are out there. And for this webinar, we're just going to focus on cutting tool process optimization and just a little bit around some of the work that we've done to date in IMR. On some of the machines that we have in IMR, we've conducted various tests around cutting tools. So we've done tool holder comparison studies between shrink and hydraulic and collet chucks. We've monitored micro boring bars where very, very sensitive or small cuts have been taken. Conducted studies on tapping systems for thread manufacturing, tool life, how to optimize tool lives, tool holder balance studies, which I'll allude to in a minute or two, and machine-to-machine comparison, quite an interesting one for companies where they might have 2 or 3 machines making the same product, but machine number 3 might be slightly different than the other 2, and they're trying to understand why they're not getting the same tool life or same surface finish. We also do a good bit around advanced toolpad optimization. So we have the latest programming software, CAD/CAM software from companies like Hypermill and Esprit and Siemens and X. And we will look to take an existing process for a company and try to optimize it with the latest tool paths and see how far you can push the tool path on the existing machine that a company might have. We do tap testing as well, which we'll go through in a second. And then we do a good bit around vibration and monitoring of the process of the spindle of the cutting tool. So as most people know on CNC machines, generally the feeds and speeds can be determined by the operator at the machine, once he gets a good feel or what sounds like an optimal process for cutting. And a lot of people know, including tool manufacturers that will provide tools, that the cutting conditions that are provided out of a book or a catalog generally are not perfect every time, and because there's a lot of variables in the machining process, and there's a lot of fine tuning to be done to find that sweet spot for machining. And digital tools can be used to visualize in real time very quickly what that optimum sweet spot is and how you can fine tune your program more effectively. And we've noticed that, and from experience myself, the first reaction for a lot of operators is to slow down the feed rate, slow down the machine till they find that the tool is lasting longer, when that's not necessarily the most optimum way to run the machine. And also to note that we work with companies like Icentio Labs, who have developed a wireless monitoring technology where they will mount a sensor onto your existing tool holder, and they will give real-time data around the machining process, and they can visualize it. And in this example here, we've actually conducted a number of tests where we're machining parts in difficult to cut materials, and we're looking to increase tool life by reducing the spikes that are observed in the interrupted cutting process. So we're in difficult materials like your Inconels, your cobalt chromes and titaniums, where you want to create a more stable machining process. An interesting aspect of this has been where we're looking at correlating surface finish on a component with the tool life or the tool wear. As a tool wear, you start to break down the surface finish you're getting on a part, but can we correlate a measurement for the surface finish related to the wear on the cutting tool insert? And we've done a number of demonstrations in this space, and then used different tool paths to try to optimize those surface finishes with the tool life as well. We're going to move on into our next piece, which is around tap testing, and I'll hand over to my colleague Gary, or Kevin, please.
Yep. Thanks, Chris. And thanks, Gary, for the introduction. So I'm going to talk specifically about tap testing, which is one of the areas of research that Chris mentioned that we're doing at IMR at the moment. So tap testing, it's not a new technology. So if you look in this picture here, there's a person doing what's called wheel tapping. So this guy would go around to train wheels, he'd tap them with a hammer, and if you get this kind of nice audible ringing when you hit it with the hammer, well, then you could say the wheel's in good condition. But if the wheel was cracked or damaged when you hit it with the hammer, you get a poor ringing tone. And so you'd be able to tell by just tapping these train wheels with the hammer whether or not they're in good condition. And it's not just train wheels, right, that you can do tap testing with. So aerospace components, bridges, and end mills specifically. And the technology has obviously come a long way since this image here. So I'm going to talk specifically about tap testing of end mills. And so end mills can experience chatter. I'm sure if you're a CNC operator or a machinist, you've all heard chatter before. So I'm just going to play it. If you haven't, this is what it sounds like. So it's really noisy, right? It's this high-pitched ringing noise. And what it is unwanted vibration of your cutting tool. And so what does it mean for you if you're a manufacturer, you're making a part? So as well as your tool or your end mill spinning around and moving along in the feed direction, it's also oscillating. You can think about it vibrating side to side and kind of hitting into the workpiece. So if you have chatter in your CNC machine or in your factory, your tool is going to get damaged. Your workpiece is all going to get also going to get damaged, and then your cycle times can be longer because it's going to take you longer to get the surface finish that you want. And then you could ask, well, how do I reduce it? And this is something that Chris alluded to earlier: is that you find an optimal spindle speed and an optimal feed that gives you this kind of chatter-free machining. And a lot of the time, that's kind of done based on intuition. But what IMR can do is perform tap testing on your CNC machine, and we can determine what feeds and speeds will reduce your chatter. And so this is just kind of a schematic of what we do. So we would go to manufacturing plants or any factory that has a CNC machine. We hook a sensor up to your end mill, and then we just hit it with a hammer. And both the hammer and the sensor are connected to a computer. So this is all digitalized. And so we can tell how hard we hit the end mill with the hammer, and we can tell what vibrations we get from this little sensor attached to the end mill. And then we use this software called Cut Pro by Manufacturing Automation Laboratories. And what that gives you is a recommended spindle speed and also a feed and what depth of cut you can cut with those two parameters. That gives you stable chatter-free machining. And so this is what the hammer actually looks like on the left. You can see there's an 11 millimeter end mill to the right of the hammer. And then just underneath this €1 coin for scale, you can see this is a little tiny sensor that we stick onto the end mill. And then that's me tap testing on the right on the robo drill in iMore. And so what we do is we take the kind of frequency information from Cut Pro, and then we take information about your setup. So your tool diameter, how many flutes your end mill has, what workpiece material you're machining. So is it aluminium? Is it steel? And then are you conventional milling? Are you slotting? And what your max spindle speed is. And what that will give us, and that we will pass on to you, is a graph that looks like this. And so there's a lot of information on this. So on the x-axis you have your spindle speed, and on the y-axis you have your depth of cut. And the main takeaway from this graph is that wherever you see blue, that will give you stable chatter-free machining. And then in the white, you'll get unstable machining. So I've just circled this kind of peak here with this green circle. And then if you go over to this data table on the right, that tells you that at a spindle speed of about 13,000 RPM and a feed rate of 10,000 millimeters per minute, and at a depth of cut, if we just go across here, of about 0.27 millimeters, you'll get stable machining. But if you reduce your spindle speed down to about 11,000 RPM to this point here in the white, you'll get chatter, and so you'll get unstable machining. And so this might explain it a bit more. So something Chris mentioned is that the intuition for a CNC machinist or an operator might be that to remove chatter, you should reduce your spindle speed, but that's not always the case. So this is a similar plot to the one before. And let's say you're operating at a spindle speed of 15,000 RPM and a depth of cut of 2 millimeters. And you can see we're above this line here. So you're going to get unstable milling. But what you can do is, after tap testing, you can say, well, if I increase my spindle speed to 16,800 RPM and I keep my depth of cut at 2 millimeters, I'll get chatter-free machining. But what I can also do is reduce my spindle speed. So I can have a smaller depth of cut at 1.5 millimeters and a slower RPM at 11,100. And these are two chatter-free regimes compared to the first one that will give you a poor surface quality. And these are both stable. And if you have a faster spindle speed, you'll get a reduced cycle time. But if you reduce your spindle speed and you have a smaller depth of cut, you'll increase your tool life. And both of these, regardless of what you pick, will give you improved surface quality. And so this is a test done by Professor Tony Schmitz. He's a world expert in tap testing. He's based out of the University of Tennessee. If you haven't, you should follow him on LinkedIn. He puts up really interesting posts. And you can see on the left here, this is an example of a cut he performed in a CNC machine that had a lot of chatter. And then he performs tap testing. And then on the right, you can see what the surface quality looks like after. I think Gary will share a link to these things at the end of the webinar. And so kind of outlined what the benefits are. So from our customer testimonials and our experience going out and performing tap testing, we've seen increases in tool life as much as 20%. And we've seen reduction in cycle times as much as 25%. And in both cases, we get an improvement in part surface quality. And when we do tap testing, we have some requirements. So it's machine specific. So even if you have two identical Mazaks in the same factory with the same tool holder and the same tool, depending on what floor they're sitting on, what machines beside them are vibrating, and even how the CNC machines are cast, their tap testing results will be different. So you need to perform tap testing for every machine, every tool, and every tool holder. And it's also vibration limited. So you need to have your machine off when we're doing this. And then we would also look at workpieces, because your end mill will vibrate, but your workpiece will also vibrate too. So we can perform an assessment on that as well. And I'm going to pass it back to Chris now, who's going to talk about tool holder balancing.
Thanks, Kevin. Yeah, just a little bit around tool holder balancing, because while we've been doing tap testing studies, we've also observed the influence of tool holders and poor tool holder balancing as well, and playing a major role. And what we've observed to date with IMR is that machines are using higher RPMs now, and previously it would have been 8, 10, 12,000 RPM. More and more machines that we're finding on the market now are 16, 18, 20, 40,000 RPM, and balance quality becomes very important. The use of smaller cutting tools becomes very important as well. Difficult materials, if you're into machining nickels, inconels, titaniums, and tool holder balance plays a big role. Long reach tool holders, a lot more companies are adopting 5-axis machining technology or mill turn technology, and they need long holders for reaching around parts. The balance quality of those tool holders becomes very influential on the process very, very quickly. Companies to look at higher metal removal rates. Tap testing is used quite significantly in the aerospace sector, where companies are removing large amounts of material very, very quickly in aluminium and structural components or in titanium, or where consistent cutting conditions are required. And we've also come across profile or special cutting tools which have been ground and specifically made for making components, but they're very unbalanced, and they need to be either designed for balance or have the tool holder balance with the cutting tool into it. And again, all of this poor balance will lead to a reduced tool life, poor surface finish, premature spindle vibration, and then excessive vibration. And we have seen all of these over the last couple of years in tests. Some of the tests that we have done, for example, on the right there, you can see a graph with tool holder comparison, where you have shrink, collet, hydraulic, and mechanical collets, all at 90mm lengths and then at 200mm lengths. And we've been able to measure the imbalance quality of the tool holder. And you can see a significant difference, particularly where you're using long mechanical tool holders versus a long shrink tool holder, for example. And we've also observed companies where they have actually had spindle failure caused by poor tool holders. And they've had spindle failure, unknown reason why. And they have given us a number of tool holders to check, and we've tested them for them and found one of their tool holders was significantly out of balance, where they could only run it at a number of, or a couple of hundred RPM, according to the balance quality. And even we've seen new tool holders coming out of boxes where we stuck them on our balancing machine, and it's like, this is poorly balanced from the start. And a lot of people point to the carbide and they go, oh, the cutting tool is breaking, and why is the cutting tool breaking? When we've done a bit of a deep dive into it and discovered, well, actually it's the tool holder that's causing the problem and not the carbide. Where on the bottom right there, you can see a graph where we've done a same piece of carbide, same end mill, and 2 different holders, and one getting a very good surface finish. On the second one, the end mill could barely even get across the part. We kept breaking the tool. It wasn't the tool, the carbide, that was causing the problem. Same feeds and speeds, same cutting conditions. It was just the tool holder itself. Okay. So just a bit around what IMR are offering in this space at the moment. IMR have been conducting tap tests and balancing of tool holders over the last year, and tool holder balancing longer than that. And we've done tests with companies on site to date, and we'll go on site for an engineer will visit a company on site. They will conduct a tap test on a machine, and then they will give information of how to optimize the feeds and speeds. You can also send tool holders to IMR. Checking the balance and quality of a tool holder is fairly straightforward. It's actually a very simple process. And we've been doing some of those assessments even for free, if it's only a couple of small tool holders that people want to check to find out what is the balance quality of their tool holder like. For going on site to do a complete study of a number of tool holders, there is funding available for some companies to explore this type of technology. And we've also offered it as a service as well to companies as well, for companies that are getting significant insights into it. And on the next slide here, you can just see some of the companies that we have worked with over the last few months. We've done more than this, but this is just a flavor of the stuff that we have seen. If you look at the second one there, for example, from the guys in DPF, they were face milling difficult material, and they were getting 8 parts out of a set of inserts on a face. Following tap testing, we increased that to 20 parts. That's a significant gain. Sorry. For tool life, and cost per part came down significantly for them. And for the guys in the bottom there, we did a study across tool holders. They were trying to justify buying more expensive tool holders for their products. They wanted to know, do I need to spend large money on hydraulic tool holders, or can I go with shrink tool holders? And they had a lot of questions before investing in levels of tool holders. And we did a study with them to understand, well, what is the optimum tool holder for their process? Okay. So that is everything we have on tap testing and on balanced tool holders. I don't know if there's any questions there, Gary, or anything that anybody wants to understand.
We do indeed, and great stuff, Chris and Kevin. Thank you both. With plenty of questions, which is great. Question: can you conduct tap testing on turning tools?
Yes, you can on boring bars. A good bit of the webinar here that we discussed is around milling tool applications, but absolutely on boring bars. And I think I mentioned it earlier, long boring bars in particular is an area of interest to a lot of companies. And long boring bars give a lot of vibration. And the video that Kevin showed earlier shows a long boring bar where somebody put a magnet on it. And I noticed somebody commented there as well about putting a piece of lead to dampen the boring bar. Very effective as well. You know, I would have put a magnet on the back of the boring bar to try and stabilize the boring bar. You can buy dampened boring bars now as well, are quite common too.
Brilliant. Have you tap tested carbide end mills with segregated edges?
Serrated edges, like a ripper cutter
Serrated,
for
sorry.
roughing tools. Yes, we have done that before as well. The same information is put into the software. You don't put in the serrated detail edge in the software, but it'll still give you an optimized cutting tool path back, or an optimized feed and speed for running that tool. The software does also allow you to put in variable helix cutters, so we're not using a standard carbide with the same index, where you're using variable helix.
Okay, another question here. How long does it take on the machine? And I suppose linked to that, there's another one here. Why does the machine have to be off to do the tap testing?
It's not that the machine is powered off, the machine just needs to be stopped. It's not something that we can do in production. So the spindle is stationary, and you saw the photograph of Kevin earlier where he has the door open and he's in doing the tap test. It doesn't need to be shut down to do the tap testing.
And how long does it take on the machine?
Typically on a tool, you're talking 15, 20 minutes per tool kind of thing, just to do the tap test, and that'll give you enough information. And then you can summarize it into a report. Some companies, we do a tap test, give the feed and speed, they optimize the program, and then we run it with the new feed and speed. Some companies we give we'll give a report after of the number of tools, and then they can go and run that program themselves with the new optimized feeds and speeds and see the gains. Then it depends on how much time they have available on the machine really to take it out of production. And we've done both, where we've tap tested, optimize the program with their engineers, and then run the new program to see the effects, or we just give the report and then they can run the optimized feeds and speeds in their own time.
Okay. Thank you very much. I'm going to get to one more question. We have a good few in there. If I didn't get to your question, we will get back to you by email. We just don't have time to get through them all. But a question here: can companies buy the tap testing software and test unit? And if yes, is it expensive?
Yes, you can buy it. And there's 2 companies in Ireland I'm aware that have it. IMR is one, and Red Key Engineering in Northern Ireland is another one. And the software is expensive. The tap testing hammers themselves are not expensive. Interestingly, there is somebody had registered for it here from Productive Machines in the UK, where you can get the tap testing hammer and then you can upload the output from it, and they will do the analysis for you online. It's an interesting way of approaching it as well. The software itself is not particularly cheap. We bought it from Mal Inc. It's in they're a Canadian-based company that we got the software from.
We'll be back in May with another webinar, so keep your eyes out on our social media channels and on your emails for more information on that. And for now, we'll leave it there. So have a great webinar, or have a great weekend, and thank you all for joining.